Hello friends and welcome. I hope you're doing great. In this video tutorial we are going to learn how to make a PCB layout using Proteus 8 Professional, and this will be done in this video manually, and in the next video we are going to see how to do that automatically. So basically the work that will be done in this video will be to place the components, the different components together, and to do also manual routing. Manual routing is all about connecting the components together using these copper wires or the lines. And also we are going to see how to visualize the three-dimensional view of the design, and lastly we are going to see how to export the PDF file in order for the PCB to be printed and used. So basically I usually advise manual placement of components and manual routing for small designs because it helps us to master the position of the components and to also determine their positions, because with automatic placement of components, you're not the one placing the components, so the computer is doing that for you, and which is pretty good. But with manual placement of components, you decide where you want to place which component, and so that enables you to have a mastery of the position of your components. So that said, let's jump right into it. So here is our schematic capture, and the schematic capture is simply a power supply. We have a 12-volt power supply right here, and above we have a 5-volt power supply. So this power supply is not having a transformer, but this T block is the input of the system, which is the output of the transformer. And it's very important to have a transformer if you have to use this power supply on a 220 alternative current voltage source. So I am going to give some brief description of what we have here, but not in details. And if you want to know about the details on how to design this schematic capture, you just click in the link above. That said, here we just have our bridge, a rectification bridge, which is made up of rectification diodes, and after that we have this capacitor, which is a filtering capacitor, and we have right here a 7805, a 5-volt regulator, and we have at our output as load we have our LED connected to the resistor R2, and that's the same thing we have here, but in this case we have a 7812, which is a 12-volt regulator, and at the output we have the same, the LED connected to the resistance R1. So this is what we are going to use in order to design our PCB layout. So when we already have the design, when we have the schematic capture, what we need to do is simply come right here to PCB layout and click there. And when you do that, a page opens. This is the page that opens, and the first thing we are going to do is to put our baud edge, and the baud edge is very important because it serves as a guide for us not to exceed, because if you exceed the baud edge, it means that those components will not have space to be connected on the board. So to do that, you simply come to this square. It depends, you can have a circular baud edge, it depends on what you want, but I'm going to take this square. With this you can have a rectangular or square baud edge. So after you've done that, you come here and make sure that you come below and make sure you select the baud edge, and after you selected, you simply come and draw it right here and click on it, and we have a baud edge. And it depends on the size of your PCB, but it's not a problem for the baud edge, because if at the end you discover that it's small with respect to your PCB after your connections, you can still increase it, or you still be able to reduce it if it is too large. So you don't have to bother about the size of the baud edge. Now after we have the baud edge, the next thing will be to place our components, and to do that you simply come to component mode, And in order to place the components, it's very simple. These are the components that are here that are listed, and the PCB designs of the components are present, and you just need to click on each of the design and place it right here, and the connections will be made later on. So I am going to make the connections in such a way that it looks a little bit like what we have here. So if we have to do that, the first thing we will need to put there is this T block, and I click on the T block. I simply come here, and I can place it here, but if I want to delete, I can right click twice and it's deleted. So when I am placing, I can rotate it by simply pressing the plus or the minus on the keypad. So that's it, that's rotating. I can place it like this, like in order to rotate. And after I have placed it, I am going to put my rectification diodes. There are four of them. I will rotate the rectification diode like this. I'm going to place it here, and also I am going to let me first of all reduce this board size. To reduce the board size, you come and click on this arrow and you click on the board size, then you can reduce it. Oops. Then you can reduce the board size. Okay, let me reduce it a little bit again. Okay, actually, to increase, what I'm doing is just scrolling in order to magnify it. You can zoom in or zoom out using these buttons right here. So I will continue, make sure this is selected. I continue by selecting this other diode and placing it right here, and then I rotate it. No, I'm not going to take this one. Let me take this other diode first. I rotate it and place it here. Then after that is done, I am going to take the next diode, get this other diode, and I rotate it and place it here. And for the last diode, I am going to rotate it also and place it just here. Okay, so that's all for the diodes. I will select it, and I will select all of this and bring it a little bit up. Okay, then as we can see, the next thing we have here after the diodes is the capacitor. So I am going to make sure we have the component mode selected, and I am going to take my capacitor and place it. I will rotate it, and the rotation, when you're making rotation, is actually to make sure that the lines cross each other the least number of times. So as you can see presently, it will not be an excellent way if I put it like this, but I can rotate it by pressing the plus or minus keypad. This one is better because the lines are not crossing, and this way it's actually the best because they are really spaced out. So when that is done, I will simply place my capacitor. I place the component, and the next thing I will decide to do is to place the regulators. As we have the regulator after the capacitor, we have our regulators. So I am going to put the 5-volt regulator just above here. I can rotate it like this. Okay, I'm going to place it like this, and the 12-volt regulator, I am going to place it just below right here. Then I am going to place my resistors. We have this resistor that it here, and I'm going to place the other resistor. After placing the resistor, I am going to place the LED, and while placing my components, I make sure that I save space a lot, because that's also very important. So after I have placed my components, I can select this now to economize space and shift it a little. But one thing you need to make sure is that the components should not be they should be a little bit spaced out, because when there's no space between them, it's probably it increases the possibility of having short circuit. So when that is done, when we have already put the components together, we can select our board edge and adjust it according to our design, to our PCB design. Okay, we can put it to be like this. All right. So we are going to make the routing manually, and to do that, you simply come to the track mode, and you get, it depends, these are the different sizes of the connections, of the connection lines. These are the different sizes, because you can take this and connect, for example, here, and this is the thickness. So these are the different thicknesses, but right now it's on default, and for me, my default is 30 th. You can still change the default. Let me go back like this. You can change the default by simply clicking on the default and increase it. You can increase the thickness, or you decrease it, or you can still, if you have this, you can, if you want a thickness of 20, for example, you can simply click right here and connect this, and it's giving you a thickness of 20. But for me, generally, I use a thickness of 20, and it's not, at times it's not good to use a very small thickness, because while you will be making the PCB, it will have possibilities of cutting out the copper lines if the thickness is very small. And also, what you need to know while making the connections is that you should avoid sharp angles like 90, because when you use sharp angles, what is going to happen is that there is a high probability that while making the PCB, the angles are chopped off, they are removed, and that will cause open circuit. So as you can see here, this angle is not sharp, so it gives there's less probability for this to be chopped off completely when the PCB will be designed. So it's pretty simple. As I said, you simply select what you want. You want T20, for example, and you click on this. And what's awesome about it is that when you click, it just directs you where it is supposed to be. So that's what's fine about the manual method. So if I click here, it tells me that it's supposed to be here. I just come and connect it, and if I click here, it tells me that it's supposed to come here, that this line is supposed to be here like this. And for this one, it tells me that it's supposed to be here, but if I pass like this, you see it's not accepting, because it's going to cause a short circuit here. So what I can do is that I can come here and pass under this resistor, and just go around like this, and come and connect it right here. And the next thing we are going to do is how to connect this, and to do that, I am going to pass under these resistors. As you can see, the software is already giving me the line or the route to follow, an easy path to follow. So for this one now, I have to I can come and pass here, for example, because it's the same. As you discover, you notice that from here to here is the same, so I can just decide and get it from here, or I take it from here and I move with it under this resistor, and I come right here and connect and make sure that it doesn't touch this other part. So when that is done, I am connecting this one. I am connecting this. Let me do it like this. And the next thing will be to connect this one is pretty simple. And we also have this connection. Let me go back. Let me do this back again. So that's all about the connections. It's very simple. There's nothing difficult in it. And I am going to connect this one also like this. Comes right here. Okay, so now I am going to make these connections. Let this pass there like this, and like this. Then for this one, I will just make it to come here, and this one is connected. This anode, this cathode is connected to this cathode, and we have this three which is connected right here, and we have this connection made. And lastly, this is what we have. So here is the PCB design for our circuit. So as we have here, we also have almost the same. They are almost designed the same way, but they can't be actually the same, because you need, in this section, you need to economize space, and if we display the components like this, it's going to occupy a lot of space, and that's not good. So after we have done that, after we have made the connections, we can still decide and add some text. We can add some text on we can add some text on the bottom silk or on the bottom copper, and I prefer to add on the bottom copper. And the text, I can write the EEE wall, the wall of electrical and electronic engineering. It works, and hit OK, and you notice that it's reversed, so that is not a problem, because when you're going to make to print it, you will see that it will be okay. So I can put it like this, and I can still decide and increase the size. As you can see, we have here the height and the width, so I can increase the height, for example. Hit OK, you see that the height is increased, and I can also increase the width or the thickness, and hit OK. So that is it, and I can now reduce this voltage, and reduce the voltage like this. Okay, when that is done, we can now see, let me make sure that this is not cut off. When that's done, we can now see the 3D visualization of the PCB. And to have the 3D visualization, we simply come here and click on 3D visualize, and we have here our PCB design. We have our PCB design, the 3D. As you can see, it's pretty simple. It's very simple, and it's just straight to the point. You see the text EEE Wolf, which is now well presented. So let me go back to our design. This is the design which has been done. It has been done, and the next thing we are going to do, we are going to see how to export this. And before we export this, let me first of all explain something here. We have But before I explain that is but before we so the next thing we have Uncle PC. So the next thing we will have to do is simply to export this file, export this in order to print it to make our PCB design. And to export it, it's very simple. You come to output, you click on output, and you click on print layout. So when this is done, you see our PCB design that's here. You can displace it on the page. You can put it on the page wherever you like. So this is the output. This is the output, and when that is done, it's good to always select to make sure this 100% is selected, because you can still increase this. You can still make it to be 500 and so on and so forth, but it's not good for it to be more than 100%, because the size of the components that you have, if you increase it, the size of the components will be small with respect to what you're going to print. And if you reduce it, the size of the components that you are going to place will be big with respect to what you're going to print. So it's good that it's just 100%. So you can decide and change the position of this. And with that, you need to check certain things here, and don't check others. So how do we do that? First of all, you need to make sure that the board edge is checked. The board edge, you need to make sure it's checked. And for top copper, you can uncheck it, because in our case we didn't use top copper, because the copper, if you check on the 3D visualization, you will notice that the copper is only at the bottom. There is no copper at the top. The top is just for the components. There's no copper at the top. So as I was saying, there is no copper at the top, so you can uncheck this. But even if you check, it's not going to cause any problem, because nothing will be printed there. And the bottom copper also is there, and we have to print the bottom copper. Now with the top silk, you need for now to uncheck this, to make sure this is unchecked in such a way that it's only the different rows that are going to be printed, because the top seal it just concerns the components. Let me just give you a look about of what is the top seal, because when you are this, all of these writings that are here is what is called the top seal. So to remove the component and see the writing well, you can come here and click on show or remove the components, and the components are gone. So everything we have here is the top silk, and generally you can print this top silk on a different paper and place it on top of the PCB layout to guide you while placing the components on the PCB board. So actually, let's go back there. So actually what you need to do is that you need to print the bottom separately from the top. So the first thing you're going to do is print the bottom. So you remove the top copper, you remove the top silk. You can allow this, or you can still remove it, but it causes nothing. So this is the bottom copper and the board edge, because that's what's important for the bottom. And you can hit OK here to do that. And I am going to save it on the desktop, and I'm going to call it PCB and just save it. And after it's been saved, you can see right here, these are the copper wires, the copper connections, and it's important, very important. And the next thing, and this copper, you can print this on a glossy paper in order to make your PCB. And the next thing, when you've done that, you still go to output, and you're now going to print the top silk. So I am going to uncheck all of the rest, all of the others, and just allow the top silk. So if I do that, I will save it to the top silk. Let's see what we have here. top silk, and this is the top silk, the different components, the position of the different components. So you can print this on the paper. You're going to cut it and place it. So when that is done, we have our PCB design. And that's all for this video. So in our next video, we are going to see how to make this same design using automatic placement of components and even automatic routing. And as I said, automatic routing is important when you have many components. When you have a bunch of components, the components are really many of them, and it's very difficult and tedious to make manual connections. So with that, automatic routing is always preferred at the detriment of manual routing. But nevertheless, for small PCB layout, manual routing okay, and it's good. So thank you for watching, and I hope this video has helped you. If that's the case, please do not forget to subscribe to my channel and hit the notification bell in order not to miss our next videos. I'll meet you for the next videos. Thank you.